All right, let's dive right into this explainer. If you're in IT support, you literally know the physical pain of staring at a never-ending wall of error logs, right? Well, today we are going to fix that by transforming all that unreadable noise into instant, actionable insights using SQL aggregation. Picture this. A critical system is going down, and you've got tens of thousands of raw error rows just flooding your screen. It is totally overwhelming. But what if I told you that using the SQL group by clause takes that blinding noise and turns it into a clean, 5-row summary in like absolute milliseconds? It's literally the ultimate lifesaver to stop you from endless, mind-numbing manual scrolling. So what exactly is it? At its core, group by is your absolute best friend for consolidation. It takes a column packed with repetitive noise, think error types, status codes, or user IDs, and collapses them down into distinct, unique subsets. By doing this, we can actually compute aggregate metrics, like counts or averages, for each of those individual groups. It's almost like sorting a giant pile of laundry into neat, manageable stacks. Okay, let's actually see this in action inside a mock MySQL environment. If we build this simple query live, we just select our error type column and then pair it with the count function. Finally, we tell the database engine to group by that exact same error type. What this does is incredibly simple but powerful. It calculates exactly how many times each specific distinct error popped up in our database. And man, this just brilliantly illustrates the raw analytical power of aggregation. Instead of 10,000 individual lines, we've boiled a chaotic sea of raw logs down into this neat 2-column table. You can instantly see that connection timeout is the biggest offender with 432 occurrences, while auth failure only has 12. Just like that, you immediately know exactly where to focus your troubleshooting. But hey, we can expand our toolkit way beyond just counting rows. SQL gives us some really powerful aggregate functions. We've got sum, which calculates the total of a numeric column, and AVG, which gives you the mathematical average or mean. These are absolutely essential when you need to dive deep into stuff like transaction processing or response time analysis. For example, let's look at tracking latency. We can apply that AVG function to a response time column and group our results by service name. What happens is this query scans through all the transaction logs and spits out the average processing time for every single microservice running in our infrastructure. So why does this actually matter? Well, imagine you run that query and a dramatic number pops up, like a 4,500 millisecond average response time for your payment gateway. You instantly know you've got a severely degraded system on your hands. That's a critical bottleneck requiring your urgent attention, and the crazy part is you found it in seconds. But here's the real challenge. When you've got hundreds of services or thousands of users logging data, your grouped results might still be a massive, unwieldy list. So we really have to ask ourselves, how do we filter out all the normal, healthy background traffic to isolate and display only these slow, problematic groups? All right, pay close attention here, because understanding this difference is crucial. And honestly, it's a huge source of errors for a lot of engineers. The where clause filters individual raw records before they are grouped together. But the having clause, that is specifically designed to filter the aggregated metrics after the grouping happens. You cannot use a where clause to filter an average or a sum. You absolutely must use having. Let's apply that rule to our latency query. By tossing the having clause at the very end, right after the group by, we're instructing the database engine to first calculate those averages and then just throw away any service groups that don't violate our strict 4,000 millisecond threshold. Now, your output is literally only the broken services, no extra noise. Real scenario, the 50 failed logins alert. Let's look at how this builds into solving a critical security ticket. Imagine an automated alert just went off for a high volume of failed logins, and your job is to find out if a specific account is triggering a brute force attack. To catch the culprit, we're going to build our query progressively. It's kind of like a forensic investigation. We'll isolate the time frame, group the data, count the offenses, and then finally filter for the extreme outliers. First up, we start with our standard where clause. Remember, where filters raw rows before grouping. So here, we're filtering the raw table to isolate only the events where the status is failed and where the timestamp happened within the past hour. By doing this, we've instantly ignored millions of healthy historical login logs that we just don't care about right now. Next, we take those remaining failed rows and group by the user ID. We'll use count to tally up the failures per user, and finally, the magic touch, we apply the having filter to that aggregated count. We're essentially telling SQL, hey, only show me the groups, the specific users, who have racked up more than 50 failed attempts. Executing this final query instantly reveals our attacker in the results grid. Out of thousands of messy log entries, the database hands you exactly one actionable row, service_admin01, with 87 failed attempts. Boom. You've successfully reverse engineered a whole security crisis down to a single data point, so you can go ahead and instantly lock that compromised account. By mastering Group by, aggregate functions like count and AVG, and that absolutely crucial distinction between where and having, you completely change how you handle system troubleshooting. So, now that you've got these powerful analytical tools in your arsenal, what massive, messy log file are you going to conquer next?